Find solutions of the differential equation e to the sine x, given that y equals 1 when x equals 0. And so that means here, if we identify the bits we're going to put into our CAS program, g of x is going to be e to the sine x. Y, that's going to be y1, that equals 1. The initial x, x1 is 0. And this is our h value, 0.1 or 0.01. Now often these questions actually tell you what step to stop at, so it might tell you to find y1 or y4 or y8, so it tells you which iteration to go to. Because this doesn't, I'm actually just going to take a screenshot and give that as my solution, but I'll show you what I mean by finding particular iterations. So let's put this information into our CAS program. So I'll just clear this so we've got a nice fresh start. So this is our Euler program. So what we need to do first of all is define what g of x is, and in this case it's the exponential of sine x, and that's done. Now we can run the Euler program. I'm just going to go over here, I just copy that, put that there. So I've got my x1, I'll just go back to my sheet again. My initial x is 0, initial y is 1, and we'll start with a step size of 0.1. So 0, my initial x, my initial y is 1, step size of 0.1. Let's just go to x equals 2, so that's not so many iterations, and press enter. So you can see what we've got there is a table of values. This tells us an x value, this tells us the corresponding y value. So given that this is our differential equation, this one here, these are actually the solutions for y for each x. So I'm just going to copy and paste this over and put this into our document. So you can see here that in terms of solutions for our differential equation, so for dy dx equals e to the sine x, we have y equals 1 when x equals 0, y equals 1.1 when x equals 0.1, and so on. Okay, so you've actually shown, I used a spreadsheet on your CAS to find solutions, and these are all your solutions for y for different x values. Now we'll do the same thing but use a slightly smaller step size. So I'm just going to copy that, and I can't fit more than up to about like 6 kind of iterations there, so I won't make it too big. We're going to make the step size 0.01, and let's just go up to 1.08. So I'm just going to go up to that. That's my x value that I'm going to go up to, and push enter. And you can see, whoa, there's quite a lot there, that it went for quite a while. Alright, so we're going to look at what that looks like. So I'll just take a snapshot of that, put that back into our document, and let's compare what happened. So you can see now we've got much smaller step sizes, so we've still got 0 and 1 as a x and y coordinate. When x equals 0.01, y equals 1.01, and then so on. So we're going up quite slowly. So if we were actually to look for one of the points here, like 0.1, there we go, 0.4, 0.2, 0.1. So there's some more coordinates. Let's compare these. So you've got here 0.1 and 1.1. Can you see that when you made the step size smaller, so this is when h, or a step size, is 0.01, see your solutions for y and x, your solution for y is more exact than this one. You only got a little bit of information here, whereas now you've got a lot more information. So using your CAS, you can find solutions for particular x values, you find particular y value solutions for your differential equation. And this is all using the Euler program that you can write yourself and store inside your CAS.